Now, what is the domain of this function? What is the range of this function? Now, let's see how to get it. I said function and mapping are brothers and sisters, or brother and sister. If a mapping has values, then it becomes a function. But when it doesn't have these values like this, it's still a mapping. Look at this, x, y, z. This is a mapping. It's being mapped into k, p, q. This is a one-to-one mapping of x to p, y to k, and z to q. This is the function it is going through, the mapping it is going through. Let's call it f. So look at it. Look at the mapping. This is f, this is x. F of x, this part, everything inside this thing, we call it the domain. Are you with me? We call everything here the image. So, or the range. Please note what I'm doing. This and jot them down, put them down. These are the basic things that will let you understand what we mean by domain and range. X is being mapped to what? To P. This is a one-to-one mapping. You know that? X to P. So we say through this function, right? That is f of x is what? Equal to P. F of x is equal to P. So we say x is the domain, while P that is gotten is the range. Please understand what I just explained. X is the domain, while P is the image. So if P could have any value like that, if P could ever had any value, then all those values from the beginning to the end will be the range. Will be the what? Range. This is y, right? When I say f of y now is going to be k, right? It is mapped to k. F of y is going to be k. Look at this. F of z is going to be q. So any value, any possible value that can fit into q is going to be my what? My range. So this is the image. The image and the range are the same. Range just gives the boundary of the image. You understand? So image is just a particular number among the range. The domain is always given. Now let us look at this function f of x equals 3x minus 4. Let's say this is my mapping, 3x minus 4. This is the mapping. This is the domain. This is the image. So any number that could be here, by using any value here, now let us see. If my x is 1, that's 3 times 1 minus 4 is equal to what? Minus 1. So my range would be having a value of minus 1. So my domain would be minus 1, right? If this is 3 times 2 minus 4, that is 6 minus 4. That is 2. I can have a range of 2. If it is 3 times 3 minus 4, an image of 2 rather, minus 4, this is 9 minus 4. I can have an image of 5. So if this thing is coming from infinity, let's say 3 times minus 1, that's minus 3 minus 4. That is what? Minus 7. Then it is definitely coming from somewhere. Then my image is that can be minus 7. So my range can be minus infinity to plus infinity. How do we get that? Let's go. Hope you understood what I just explained with image and the domain and the range now. Like I mean the first thing I did. This one is just to illustrate. I'm explaining this one better now. I mean, hope you understood this mapping. So let's take the reality now. So the domain, this is the function. Find the domain, I, the range, then I. the inverse. We treated inverse in the last class. We have number one. I think my handwriting is too small. 1, find the domain. I find the range, and I find the inverse. How do we look for the domain of a function? That is quite simple. The function is given to be 3x minus 4. So the domain of this function is any number that you can put into this thing, into this x. Any number that you can impute into x and give you what? Anything. That is, you can put any number into x and you will have a value. You will have any value. So I believe if I put minus 1 million here, I'm talking about something I'm going to infinity, close to infinity. Minus 1 million here, that's 3 times minus 1 million, right? Minus 4. That is going to give me minus 3 million minus 4. That is minus 3 million and 4. Definitely, I still have a value. Okay, what if I'm using 1 million? Positive 1 million. 3 times 1 million minus 4. This is going to give me 3 million minus 4. This is 299,996. So I still have a value. So definitely, if I'm coming from minus infinity, I will still have a value. If I'm going to plus infinity, I will still have a value. Then we will say that the domain of this function is all numbers. But to make it more precise and concise, we say all real numbers. I can explain again if you didn't get it.
Yes, please come again.
Okay. I said the function is given as thus, 3x minus 4. Now find the domain means up to what value can we solve this work till it keeps occurring. So this one now, there is nothing that will not be possible for the domain. If you put 3 times 1, that's 3 times 1 minus 4. If you say, let's make the domain 1, so that's f of 1, right? 3 times 1 minus 4, that's still giving you something. That's minus 1. If you use f of 2, that's 3 times 2 minus 4. That is what? 6 minus 4. That is 2. You are still getting an answer. There is nothing that you will impute that you will not get an answer. Even if it is 3 times something that will give you 0. Let's say 3 times, what's going to give me 0 here? 3 times 12. Okay. 3 times, I'm coming. 3 times 4 over 3. That's 3 times 1.33. Let's say I'm taking f of 1.33. 3 times 1.33 minus 4. The answer is going to be 0. My brother and my sister, I'm still having 0. 0 is still a value. So far I'm having is equal to something. That the result is defined. The answer is not undefined. So far I can write it into calculator and the calculator can display 0. So far calculator can give me 0. So far calculator can give me an answer for anything I'm imputing. Believe that it's all numbers that can go for that thing. So it will be what? All real numbers. The domain will be all real numbers. Why? Because the numbers can still be defined, or they are still defined. The function given is defined. For a function like this now, if I'm using any number, irrespective of how small it is like 1 minus 1 million, or how big it is, like 1 million, I would always have an answer. It is always equal to something. In some cases, it will be equal to math error if you use your calculator. That will be my next example. You will understand it better then. Or next 2 examples. So look at this very well. I can use any value for x and still get something. So far I can still get something. believe that all real numbers are possible for this work. Okay, let me try to use a simpler example. I don't know why people find it hard to understand what's it called? Range and the rest. Let's say I'm having x minus 2. Okay. Now look at this. F of x equals x minus 2. You know, if I use minus 1 as my x, that's f of minus 1. That is what? Minus 1 minus 2. That's what? Minus 3. Right? This is f of minus 2 minus 2 minus 2. This is minus 4. This is f of minus 3 minus 3 minus 3 is what? Minus 3 minus 2 minus 5. And like that, if I keep going. Now, let me get to the positive side. You know, definitely all negative integers are possible because I'll always be having answer. But look at this, f of 1. That is 1 minus 2 equals minus 1. I think I made a mistake in my last example. I hope I'm able to cover it up so fast and easily, so I won't confuse people. So f of 2 is equal x2 minus 2. So this is equal to 0. It has spoiled the function. So definitely 2 must be exclusive. 2 should not be among the numbers. Let's go. F of 3, continue. That's 3 minus 2, right? 1. F of 4, that is 4 minus 2, 2. You can see that all others are giving me answers except f of 2. F of 2 gave me the value of 0. So I will say all real numbers are domains of this function except 2. Because when we use 2, we got 0. So all real numbers are domains except 2. So all real numbers except 2. That is the meaning. Is it clear now? Okay, at least if I think a person, 2, 3 people got it well. 4, 5. Okay, they are already getting it. Let me explain this again then. I hope they will get it better now. I said what is happening is f of x equals x minus 2. What is the domain? The domain means the value I can input here and get a value again and get another number. The value that I can input that still renders this function valuable. I can still see this function is still continuing. So if I use f of minus 1, it will be minus 1 minus 2, that is minus 3. You can see the function is still going well. So minus 1 can be a domain. Minus 2 can be a domain. Minus 3 can be a domain. 1 can be a domain when we used 1. So by this, we are able to see that negative numbers can be domain, positive numbers can be domain for this function, except when it got to 2. 2 minus 2 becomes 0. It spoiled the function. So definitely, all real numbers are domain except these 2. All real numbers are domain except 2. So let me take this one now. F of x equals x minus 3. I'm very sure you understand it now better. Let's say f of minus 1, that is minus 1 minus 3. That's minus 4. F of minus 2, that is minus 2 minus 3, minus 5. F of minus 3, that's minus 3 minus 3, that's minus 6. F of 1, that is 1 minus 3, that is what? Minus 2. F of 2, that is 2 minus 3, that's minus 1. F of 3 is what? 3 minus 3, that's 0. This one has spoiled the function. F of 4 still continue. 4 minus 3, that is 1. So every other value will give us something meaningful except 3 itself, because 3 minus 3 gives 0. So the function is doomed at that point. So all real numbers will be the domain of this function. All real numbers except 3. That is the meaning. Did we get it now? Great. So all real numbers except 3. That is to get the domain. Let's take a more complex function, 3x minus 2 now. 3x minus 2. So, talking about real numbers now. Real numbers. Let's say, taking f of 1, taking 1 first, we have 3 times 1 minus 2. That is what? 1. Taking 2, f of 2 is 3 times 2 minus 2. That is 4 minus 2. That is 2. F of 3 is 3 times 3 minus 2. That is 6 minus 2. F 9 minus 2. That is 7. So if we take negative values too, 3 times 2 minus 2, that's 4. So if we have these values and keep taking them that way, we see that there is no real number, one real whole number that will be used that will give us this. So we say that will give us 0 rather. Then we can say that all real numbers can go for this. All real numbers can be the domain of this function. Because there is no function that we used that eliminated this function and turned it to 0. There is no value we used that turned it to 0. That's a whole number that turned it to 0. That's why we can say all real numbers are domains of this function. Maki, what's your question?
So my question is that what if we use the value 4/6?
In that case, 4/6 is not a real whole number. It's not a whole number. That's it.
Oh, we can't use fraction.
Whole number. Now we're mentioning whole numbers.
Okay, sir.
Any question? Any other question? Let me assume that is gotten. So what is now the range? Look at it, guys. The ranges are all this, or the range. We have one here, one of the ranges, one of the range. It constitutes the range. 4 is there, 7. These ones are what we mean by the range. All these ones are what we mean by the range. Now, if this is the function x plus 1, should I get to this point now? 3x plus 1 like this. The range can be anything, any real number. Because if I use minus 1 plus 1, that is 0. So the domain can be all numbers except minus 1. The domain can be all numbers except minus 1. Because minus 1 plus 1 renders the function 0. It renders the function impossible. So the domain can be all numbers, all real numbers except minus 1. So now, if we forgot minus 1 now, let's take other values, like minus 2 plus 1, that is minus 1. This is one of the range. Minus 3 plus 1, that is minus 2, can be the range. So any number can be the range. Any number can be the range. Any number, positive number or negative number, can be the range. So the range of this function is all real numbers. So let's solve the question we have as an example. I never even imagined it would be so hard to explain. I've explained it to some students. Yes. Range and domain. 3x minus 2. The domain now, the domain of this one will be all numbers. All numbers, all real numbers that we can use. We'll still get something meaningful. Use minus 1, you get an answer. Use minus 2, you get an answer. Use minus 3, you get an answer. Then start using 1, 2, 3, you still get answer. So the domain is all real numbers except, all real numbers except nothing. The domain is all real. All real numbers. All real numbers. And the range will also be all real numbers. What do we mean by all real numbers? That is from minus infinity to infinity. That's the meaning. All real numbers to here, from minus infinity to infinity. From minus infinity to infinity. It might come this way too. That is the meaning of this one. Now let us take, we all know how to find the inverse. Let me wait for you. Guys, so find the inverse of f of x equals 3x minus 2. Let's see the person that's going to have the inverse here. Inverse of the function f of x equals 3x minus 2. Some of you might be able to solve it offhand. So any person, the inverse of the function f of x equals 3x minus 2. The inverse of the function. Prodigy, that's very perfect. Another person. Another person, guys. They're waiting for you. The inverse of the function. The inverse of the function. Another person. Okay. X plus Ola, that's great. Maki, I'm expecting yours too. Nwabiuku, Naomi, IJ Tech or something. Amuche, Kingsmith. All of you are here. I'm expecting your answers, Joe. Yeah, find the first part. Great, Maki. Wait, is it your this thing that is having over 3? Your 2 over 3? Is it your 2 that is having over 3 or everything is having over 3? Those of you that just submitted now.
Everything now.
Perfect. You are supposed to put a bracket and write that in the bracket and that go over. Okay. Guess what next time? Better. Okay, waiting for you. I think we've seen some. That's it. Kingsmith, you don't get that. Go watch video. I read the poster. So let's keep going now. That's that as part this. So by solving examples, actually, just this one explanation should be able to tell you how to get range and domain. But you need to solve examples. I promise you. When you solve examples, you are definitely going to be very perfect in it. Inverse. Inverse was explained in the last mathematics class. Ask for the link. I shouldn't explain that here again. Okay.
Please, can you show me like 2 over 3? X plus 2 over 3. Please, can you show me like
Yeah, that is correct. That's correct. So, continuity of the function. You know, all functions can be represented on a graph. We have graphs of curves. We have graphs of lines. I explained several curves of graphs these days. I think the first class. I said this is the graph of sine. This is the graph of cos. Same difference in physics. So I said this is the graph of tan, starting from this place. We mentioned the graph of x squared. It's like this. Graph of x cubed, like this. Graph of what again? We have so many things. So many things. So now, a function is said to be an odd function. We have odd function and even function. The function is said to be an odd function if the power of x in that function is even. Finish. When it is an even function, the power of x will be even. X squared plus 3x minus 4. This function is an even function. F of x equals to this polynomial. So this function is what? An even function, because the power of x here is what? 2. x is raised to the power of 2. So it will have the shape of x squared graph. If it's x raised to power 4, it's still an even function. The shape is going to be like this somehow, this parabola. So if it's x raised to power 6, it's still going to be like this. It is an even function. But an odd function will be x raised to power 7, x raised to power 9, x raised to power 11, x raised to power 5. All these are odd functions, and the shape of their graph is going to be like this. Okay. I'm not polite for rubbing it off so fast. Let me take the one I just dropped off now. So these are odd functions, and even functions are going to be in this parabola form, while this one is going to be in this stretched back form. Okay, even function, x raised to power 2, x raised to power 4, x raised to power 6, x raised to power 8, and the likes. So this one, even function, this one, odd function. Even, odd. Did we grasp that information now? Prodigy did that. Any other person that got the information? Okay. I agree with you. Thanks for yesterday. The person has better done it. Thank you. So that's great. Mr. Tochukwu, is there any issue? Okay, again. X raised to power 7. 7 is an odd number. That is why any function that's having something like this will be an odd function. And the graph of the function will be in this form. It might not pass through the origin, because the thing might already have plus 2x minus 3, all those things. So it might not pass through the origin, and it might pass through the origin, depending on what other things the x raised to power 7 is having. But basically, it's going to be in this shape, this form. While that of this is going to be in the parabola form, even number. So if it's x squared minus 2, then I just have to remove 2 from x. So shifting, we have something called shifting, transformation of graphs. That's what I'll be taking here. I didn't see what you asked. Please say it. I didn't see it, or you retype. I didn't see it. So that's that as for this.
Please, the light. Wait. We're not seeing that down graph.
Okay. Oh. All these markers they are doing, they are too bad. I've got several markers that are all just bad. And my ink is not, I don't know, ink self is not, see, Igbo ink. But the ink is not, it's big, it's just appearing as if it's small here. How many kilograms? But the ink is not dark. I don't know why. See all the markers too. All the markers too are acting weird. New markers acting weird. So that's why, please, you just have to bear with me and let me shine. This, well, you guys should go and take shine your face. Ask Prodigy, he knows about it. He take and they play new. Okay, so when a function is continuous, how do we know? When a function is not continuous, how do we know? Continuity of a function is based on some few things. That is, the graph of the function would be drawn without dropping the pencil, without any, look at it, let me take it slower. This is the graph. This is the graph book. This is the graph of the function. I want to draw it. You can see that my pencil keeps going. It's not stopping until it gets to the destination. A graph that could be drawn like this is a continuous function. The function that is having this graph is a continuous function. But once the graph is like this, look at it. I'm having a hole somewhere or a gap. See? I'm going to jump this place. You see? I'm putting a hole there. So far I've jumped that place. This function is not continuous. And at what point is it not continuous? At this point that I'm jumping. It is not continuous. It is not continuous at that point. So a continuous function can have its graph. Please, we can have the definition. The graph of a continuous function will be drawn without removing the pencil, without raising the pencil at all. I'm going to explain it better with some workings. So a continuous function now will have its domain to include all real numbers. A continuous function will have its domain to include all real numbers. While it is, I think you should get that information. A continuous function, so we have its domain to be all real numbers. While a discontinuous one will not have its domain to be all real numbers. It will have some deviations. That is the definition. A continuous function will have its domain to be all real numbers. A continuous function will have its domain to be all real numbers. Now tell me, you are the one that will answer me. Let me take one person. Joy, please answer this. This is the function f of x equals x minus 2. F of x equals x minus 2. Is f of x continuous at point 2? At 2, is f of x a continuous function at point 2?
It is not continuous because the result is going to be 0.
Perfect. That's what we mean by continuity. So if I'm going to draw this graph now, the graph passing through, if my x 1, 2. So the graph is going to be having an issue. When an issue 1, 2, when it gets to 2, see, you know, as it's been coming from infinity. When it gets to 2, it will jump 2 and it will continue going. Because when I use 1, it's still coming. When I use minus 1, it's still coming. But when it gets to 2, it will jump. But when I use 3, it still continue going. So that 0 that it will give you when you use 2 should just be at the top of the 2. So you can see when I'm drawing the graph of this function now, I remove my pencil for once and I'll continue from this place. That means the function is not continuous at that point. Did you understand?
Please, I'm lost.
Okay.
I'm lost.
This is f of x, x minus 2. I said the function could only be continuous at this point if its domain has all real numbers. That is, if all real numbers would be its domain. But now it's not all real numbers that can be its domain. See, 2 minus 2. That means it is not continuous at point 2. It is always continuous before. But when it got to point 2, it is no more continuous. And after point 2, it keeps being continuous. That's the meaning. When we used 1, when we used minus 1, we had f of x is minus 1. That's minus 1 minus 2. That's minus 3. When we used minus 2, we had a value. But when we got to 1, we still had a value. When we now use 2, we had 0. Let that 0 be at the top of your 2. The 0 you got, write it at the top of your 2 in the graph. So now, you've been using everything. You used minus 100, minus this. Everything has been going through. But when you go to this point, you have to jump it. So you raise your pen or pencil and you continue after 2. So since you can raise your pencil and continue after something, so I can say that the function is not continuous. Did I make it clear, everyone? The function is not continuous. Just 2 people, 3. Again, I'm taking another example. IJT, please listen better. This is f of x equals x minus 6. X minus 6, you know, it will be continuous at all aspects. So this thing is just technical. Normal brain. I believe in you guys. So x minus 6, you know, all real numbers will enter it except 6. So it will not be continuous at 6. So since it's not continuous at point 6, when I'm drawing the graph, when I get to point 6, I'm going to raise my pen. Once I've raised my pen, know that the function is not a continuous function. Finish. Prodigy, did you understand my explanation very well? I'm quite sure of that. Sure. Now, listen again, everyone. F of x equals x minus 6. When I'm trying f of minus 7, I'm having minus 13. That is a value. Try f of minus 6. I would have minus 12. F of minus 5. I'll have minus 11. F of minus 4. I'll have minus 10. F of minus 3. I'll have minus 9. F of minus 2. I'll have minus 8. F of minus 1. I would have minus 7. F of 0. I would have minus 6. F of 1. I would have minus 5. F of 2. I would have minus 4. F of 3. I would have, you can say I'm having values, I'm having answers. F of 3, I would have minus 3. F of 4, I'll have minus 4. F of 5, I'll have minus 1. But F of 6, I'll have 0. That's 6 minus 6, 0. So once I'm drawing the graph of that thing, this is 1, 2, 3, 4, 5, 6. 6. So at point 6, I'm having a 0. So, but it's been continuous. You see, I've been coming from minus, 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 till I got to plus, plus 1, plus 2, plus 3, everything. The graph is still okay. But when it got to point 6, I have to stop my pen first due to this hole here. Due to the hole at point 6, I have to stop my line first and continue later. So because of that, the function is not a continuous function. Miss Destiny, let's hear your question. Let's hear your question.
Okay, I don't know my video. I'm not seeing anything you're writing. So the video is not visible. I don't know if it's network or it's from my side. I'm hearing what you're saying perfectly, but I'm not seeing what you're doing.
Small. Wait, excuse me. Just spare me 30 seconds. 30 seconds. Let me check the markers.
Okay.
It's clear, sir. I don't know if you pin your end down. The video is clear for me. Pin it down.
I've pinned you. I'm not seeing anything on the board. I'm not even seeing the board at all. I'm hearing you, but I'm not seeing anything.
You definitely your network is affected.
Yes, this is clear.
Your network is affecting you over there. It's shooting you. Let's continue. I'm having another.
Maybe you can leave the call and come back again.
As an advice. So this is a function f of x equals x squared over x. So when I'm solving this, before I can say I want to use limit, it will be okay that x squared, x minus 1, x minus 1. So, but this one will cancel this one. I will have what? X plus 1. X minus 1 as my value plus 1. This is going to give me 0. So minus 1 makes the function not to be having a straight line, a graph that will be drawn without raising the pencil again. So this function is discontinuous. As simple as this. You'll be determining when a function is continuous or not. Let me explain again. F of x is x squared minus 1 over x minus 1. When drawing the graph of this function, you can finish it first. X squared minus 1 can be factorized as x minus 1 times x plus 1 over x minus 1, right? This x minus 1. X minus 1 cancels x minus 1. I have x plus 1. So if the graph of this thing is being drawn now, x plus 1, all real numbers will satisfy this function, except what? Except minus 1. Because minus 1 plus 1 gives me 0. So far I can have except, that's it. So far I can have except something, so that the function is not continuous. So far I can have all real numbers except this. That exception makes the function discontinuous. Think about it. So that's when a function is continuous and discontinuous. It's just a pity I don't have much examples here. I don't have much examples here. So I would have loved an example that I give you that are in the material, but I really don't have access to that at the moment. So a piecewise function is as simple as something else. A piecewise function is a function that is having more than one function inside it. Piecewise function is a collection of functions. This is f of x equals 5 at minus 2 is less than or equal to x is less than or equal to minus 2 and x minus 1 at x is greater than or equal to 5. So this is what we mean by piecewise function. They might not even need you to do anything because I don't believe they will ask you to come and draw graph in your OBJ. So they can just ask you what type of function is this. It is a piecewise function because it contains more than one function. If I'm drawing the graph of this one now, I'll have 5 and minus 2 here. The thing will be coming from infinity. And I will have another one here going from minus 5, from plus 5 here. Let's say this is my 5 coming this way. You can see I have two different graphs, two different lines or functions in the same graph. Because I have two different functions in the same graph, I can say it is a piecewise function. I will collectively call this graph the graph of a piecewise function. Did I explain it? Okay. A piecewise function contains more than one function. I've drawn it. Let's say, okay, now I'm using x is greater than minus 3 now. The value of x is 5 when x is less than or equal to minus 2. I will not be explaining how I'm getting my graph for you. See, coming from this point, going to this point, let's say this is 5 and minus 2. Y is 5 and x is less than minus 2, less than or equal to minus 2, coming from here. This is a function here. This is the value of the function gotten. Another function is now coming, x minus 1. So x is greater than minus 3. Minus 3 is here, right? So minus 2 and all these ones are here. So it's going to come from this place. X minus, okay, minus 1 is here. So it's going to come from this minus 1 at the top here. So this is another function inside this same graph. Forget about how I'm getting my graph. It's not so important to you now. So, but this is one graph containing two functions, two different functions. So the function, we will collectively call the function of this graph now, we will collectively call its function a piecewise function. We will not say there is one function inside it, there's another function. No. We just call it together as a piecewise function. That's it. That's what we mean by a piecewise function. Great. Okay, I think we're able to take function to an end. So now, without wasting much time or thinking much, who can tell me the domain of this function and the range? X squared. Very technical. The domain of this function, x squared. Function x squared. Yeah, you are telling me it is continuous. I know it is continuous. This is going to be entirely continuous from minus infinity to plus infinity. Yes, it's going to be like this. But what is the domain of this function, or what are the domains? I think Joy was mentioning something. I couldn't hear her. The domain of the function. Anyone that gets it right, I will try and do it. Maybe I get you. You play. Real number, all real numbers. IJTech, you tried, but Synovial consult, you are perfect. All real numbers can fill here. Minus 1 will give you minus 1 squared. Minus 2. So now, what is the range? The domain is gotten, right? All real numbers. All real numbers can be inside this thing. And you will get an answer. There is no one that you say something squared will give you 0. So far, you cannot have something squared that will give you 0 that you now say except. So this function is a continuous because of that. Because all real numbers enter Right. Now tell me, what will be the range of this function? Is it still all real numbers? The range of the function.
All
Minus
real
infinity.
numbers.
So since you said minus infinity to plus infinity, you mean all real numbers.
All real numbers
Kingsley,
too.
2 is range. X is domain and 2 is range. That is very wrong. And Kingsmith, that is also wrong. Geoistics, square of all real numbers, synovial construct, you are perfect, but it's not so well. Give us how it will come. Give us the range. GOE. Oh, who's this? Kara, perfect. Everyone, look at what Kara just sent in. That's exactly what we want. All non-negative numbers. Because that's why I said synovial is very right, but not so perfect. See now, minus 1 squared is going to give me plus 1. There is no way I will use any real number for this thing to get the negative number again. So all non-negative numbers will be the range. You agree with her. Kara, you did very well. I don't know if you are a she or a he. So that's very perfect. That was what I was expecting exactly. So 1 minus 1 squared, 1, minus 2 squared, 4, minus 3 squared, 9, minus 4 squared, 16, minus 5 squared, 25, minus anything squared is still going to give you a positive number. And also, something itself squared. That means the square of a negative number gives a positive number, and the square of a positive number gives a positive number. Definitely, the range will be all positive integers, all positive real numbers, all positive real numbers. Joey, let's hear you. Speak out, please. Joey sticks. Okay, forget it. So, Kara, you did well. That was great. And everyone, I hope you've gotten it. Let me give one more example. One more class work, rather. The function f of x is equal to 3x, 2x minus 3. Number 1, find the domain. 2, domain 2, find the range. 3, find the inverse. Let's everyone do this here. 4 is the function continuous. Determine the continuity. Okay, I'm here for you, everyone. Please just raise your arm once you've gotten the answer. Don't just type it out. Wait, Kingsmith, I'm here.
Okay. The domain is all real numbers.
The domain is all real numbers. That is right.
The range is the same, all real numbers.
That is right.
Then the
What's your inverse?
is s plus 3 over 2.
That is perfect. That is right. Inverse is correct. The continuity.
It's
Is it okay? That's
continuous.
what you are saying. So is the function continuous or not?
It's continuous.
It is continuous. All right. That is very perfect. Everyone, if you believe it is correct, or no, because it's very correct. If you think you also got what he got, let's see the way we'll have it. What he got. Any other person that Mr.
This one
Abel,
you
let's
say
go.
is the inverse. I've not heard the inverse. No.
Okay, you said the
The inverse, I've
inverse
not heard it very well.
the
Eh?
inverse is x plus 3 over 2. That is the inverse.
Okay, thank you. I understand.
All right. Okay, I think many people concur with you, Kingsley. So, and that's it's time to enter limit. It is time to enter limit. And after entering the limit, we will at least achieve one or two things, then call it a day. Okay, I think we are getting one or two things from this, everyone. Wish us the best. Limits. When we talk about limits, oh, you have a question? Mr. Abel, speak first.
Sir? No, that's no need.
Okay, Prodigy, your question.
Thank you.
Prodigy. Prodigy, do you have something to say? Okay, nothing. Okay. Okay then. Talking about limits. Limit is not just limit. It's not like it is limit. It's evaluation. Limit in this sense is evaluation. It's not like limit. What we mean by limiting it is, are they hear me? Your mic, please. Are they hear me? What do you have to say or ask? Mr. Adeyemi. Okay, we said limit. When they say limit this thing to this or limit this as it approaches this, what they are trying to tell you is just that use this value to represent x. As simple as that. Look at this. Limit x to 7 in x squared minus 2x plus 4. Everyone note this. Limit x to 7 in x squared minus 2x plus 4. What they mean is to represent x by 7. Finish. Let's do that. 7 squared minus 2 times 7 plus 4. That is what? 49 minus 14 plus 4. The answer is going to give me 39. So that is the limit. The limit of this function as it approaches 7. The limit of this function as it approaches 7 is 39. That means if this function is f of x, then f of 7 is 39. It's because the function is continuous actually. Are we together? Or could it, okay. Or could it be non-continuous at some points? Perhaps. Okay, then let's take more. The limit has theorems, the limit theorems, and the limit rules. But before that, let me take one more thing about limit. Not everyone has understood it perfectly. X, limit x as it approaches minus 3 for the function x cubed minus 3x plus 7. Shall we? Solution. Minus 3. Limit x as it approaches minus 3. That's minus 3 cubed minus 3 times minus 3 plus 7. That is what? Minus 3 cubed is minus 27 plus 27. 3 times 3. 3 times minus 3, that's 9 plus 7. So the answer is minus 27 plus 16. And that's what? Minus 19. Okay. Are we moving well? Or
Yes.
minus 9?
Please come again. Please come.
Okay. You said this function, this is
Minus 11, bros.
anyway. Okay, meet your mind.
Minus 11.
Sometimes that thing is always affect. Thank you, Jerry. So minus 3 square minus 3 cube, limit x as it approach minus 3 for this function. So minus 3 cube, that's minus 3 raised to the power of 3 minus 3 times, what is x? Minus 3 plus 7. That's minus 3 cube is minus 27 plus, minus times minus gives plus. 3 times 3 gives 9. And the 7 is there. Everything is just mathematics. You can take your calculator to do the evaluation. So limit now has the upper limit, it has the lower limit. We have the left side limit, we have the right side limit. I want you to note that from this. Let's say this is the limit. So the left side limit will be x, limit x to minus 3. So left side limit will be taken this way, minus 3, raised to the power of minus. If it is the right side limit they are talking about, it will be raised to the power of plus. So now, if we take the right side limit of this function, we will get 7. If we take the left side limit of this same function, we are going to get 7 because they are the same way. So since the right side limit is equal to the left side limit, so just take the value of the right side and left side limit, which is 7. But instead of going through all those stress, you can just say, since this is how it is given, so minus 3. So I only explained something to you now. Right side limit and left side limit. Be familiar with it. We are going to use it to work. The laws of limit or theorems of limit. As for limit x to a, b plus c is equal to limit x to a, b plus limit x to a, c. This thing showing like this. We are gonna go shine eyes. I said this is the first theorem of limit, that the sum of the limit of a sum is equal to the sum of limits. The limit of a sum is equal to the sum of the limit. So limit x to a, non-distributive property, is applicable to limit. Limit x to a. So we can rewrite it as limit x to a, limit x as it approaches a for b plus c, can be written as limit x as it approaches a for b plus limit x as it approaches a for c. It is also possible for negative b minus c, that is limit x to a for b minus limit x to a for c. Are we getting the point? Please, you might not be seeing it so well, but just manage, please. Are you getting what I'm explaining? I want to finish it before the event.
No. I didn't get it.
You did not get it. I'm not explaining anything. I'm just like, I'm giving the rules now. Chidima, what's the question? Okay. I said these are rules. I'm not the one forming them. They are theorems established before. That if you have limits, I think we have to stop very early, even before 10. So, so limit x to a for b plus c. So if it's not b plus c now, let's say 7x squared plus 3x. This is the meaning of, not what I'm doing now. For the first one, that limit x to a, b plus c, can be written as limit x to a for b plus limit x to a for c. This is the same as writing limit x to a. Let's say, don't let me limit it to a, let me limit it to 2. For 7x squared plus limit x to 2 for 3x. This can be solved, right? Limit x to 2 for 7x squared, that's 7 times 2 squared. Plus limit x to 2 for 3x, that is 3 times 2. This is 7 times 4 plus 3 times 2. That is 28 plus 6. That is 34. Did you get what I did, guys?
Yes, yes.
Mercy. Okay. That's great then. So now,
I did not get it. I didn't get it.
okay, you didn't get it. Listen again. Mute your mic, please. Mute your mic. Listen again. We said limit. This is one of the theorems of limit. The rules of limit is that when to limit x plus a, that is limit x as it approach a for the function b plus c. This is sum of two different functions. This is a function b, another function c. So you can as well write it as, and it might even be a polynomial, just a polynomial like this. So you might write it as limit b as x approach a plus limit c as x approach a. That's what we are now doing here. If that is not so clear, look at this. This is the question. Limit 7x squared plus 3x. And 7x squared plus 3x. Limit x to 2. So that means we can write it as limit ordinary 7x squared first as x approach 2 plus limit 3x itself again as x approach 2. So now we have to limit x 7x squared as x approach 2. That will be 7 times as x approach 2. That will be 2, right? 7 times 2 raised to the power of this 2 that is here. Plus 3 times x, that is 2. So 7 times 4, that is 2 squared. 7 times 4 plus 3 times 2 is 34. So now let us assume it is minus so as to verify this second theorem. Then everything is going to turn to minus. That will be 7x squared minus 3x as x approach 2. So that will be limit x to 2 for 7x squared minus limit x to 2 for 3x. Now, x to 2 for 7x squared, that's 7 times 4 minus 3 times 2. That's 28 minus 6. The answer is then 22. Are we moving together? I think, Brody, we'll have first class before the next official class. I mean, the next, what's it called? The next mass class. That will be on Thursday. So before Thursday, we'll have another mass class. So I'll be able to make up for today because my marker is even vexing this. So I hope
maybe we should have it on Monday if you are chance.
This month, if that look on me.
Can we have it on Monday?
Do we not have any course on Monday? Don't we have
On
any?
Monday, Monday.
Yes, we are not having any.
We have course on
Monday is fine. Monday is fine. No.
If we don't have any course on Monday, perhaps we could take it.
Okay.
Because I think I'm about to retire now. The marker don't make work, tire me. I just did force myself since. So those are just 2 theorems. We have more theorems to take. We have more and more to take. So multiplication theorem is also there. Addition theorem is there. Limit of a constant is there. Quotient is there. That is division theorem. Okay, do you have a question? Please, let's entertain your question now. Miss Joy, how much? You know, wait.
Okay.